Welcome to this tutorial on using Excel's binomial distribution function to calculate binomial probabilities. In order to demonstrate the binomial function, I'll first show how a simple problem can be solved manually, and then I will demonstrate how we can use Excel to solve the same problem. You can skip ahead to the Excel portion, but you will get a lot more out of this tutorial if you first watch how the problem is solved manually. Okay, here is the problem we will use. Suppose we have 5 customers at the local ice cream parlor. From past data, we know that 29% of customers order vanilla-flavored ice cream. What is the probability that none of the 5 customers will order vanilla flavor? Let's first solve this problem manually using the binomial formula, and then let's use Excel to solve it. As you can imagine, solving it using Excel will take a fraction of the time it takes to solve this problem by hand. To solve this by hand, we would use the following formula. This formula calculates the probability of x, that is the probability density function for a given x. This means that the formula calculates the probability of x number of successes given n and p. In our case, how likely is it that none of the customers order vanilla ice cream given the number of customers n and the probability of ordering vanilla p? As you can see here, n is defined as the number of observations, so since we have 5 customers, n is 5, and p is the probability of a success, which for our example is 0.29, since past data shows that 29% of customers order vanilla-flavored ice cream. X is the number of successes we have in the sample. For this example, we are looking for the probability that none of the customers is going to order vanilla flavor, so X is none or 0. So let's fill in the formula for the binomial distribution by hand, and then we'll do this using Excel. For this example, we have n equal 5, since there are 5 observations, that is 5 customers. We have p equal 0.29, since the probability of a success from past data, that is of customers ordering vanilla flavor, is 0.29 or 29%. And finally, we want to know what is the probability that none of the customers will order vanilla. So none is 0, so x, the number of successes, is 0. So filling in the formula, we get the probability of x equals 0, that is the probability that none of the customers will order vanilla ice cream, none is 0, right, so 0 successes, is equal to n factorial, so n factorial in the numerator is 5 factorial, over x factorial, so in the denominator x factorial is 0, times n minus x factorial, 5 minus 0, which is 5 factorial. You might recognize this part of the formula as the combination formula when you studied combinations and permutations. Next we have p to the x power, so that's 0.29 to the 0 power, and then we have 1 minus p to the n minus x power, or 1 minus 0.29 to the 5 minus 0 power. Okay, so let's work this out by hand, and then we will do it using Excel. We get for the first part the numerator of 5 factorial, so 5 factorial is 5 times 4 times 3 times 2 times 1, and then the denominator is x factorial. Now remember, x is 0, so by definition 0 factorial is 1. And then we have n minus x factorial, or 5 minus 0, which is 5 factorial. So we have again 5 times 4 times 3 times 2 times 1. So in the numerator we have 5 times 4 times 3 times 2 times 1, and then in the denominator we have 5 times 4 times 3 times 2 times 1. So all of those cancel each other out, and we get 1 over 1, which of course is 1. Okay, now next we have 0.29 to the 0 power, which is also by definition 1, and then we have 1 minus p, or 1 minus 0.29 to the n minus x power, so that's 0.71 to the 5 minus 0, or to the 5th power. And 0.71 to the 5th power is 0.18042. So the answer is 1 times 0.18042. So of course the answer is 0.18042. That is, the probability that none of the customers will order vanilla ice cream is 18.042%. To do this in Excel, we will use equal Binom.DIST function. Remember, functions and formulas in Excel always start with an equal sign. And the format is as follows. We have equal BINOM.DIST, binomial distribution. And then in parentheses, we type in X for the number of successes. Then we type a comma, N for the number of observations, comma, P, the probability of successes, comma, and then we would type in either true or false depending if we want a cumulative answer or not a cumulative answer. Now we don't type in X, N, and P, we type in the numbers for X, N, and P. And in the previous problem, X was 0, N was 5, and P was 0.29, right? So we will type those numbers into this generic formula. Okay, the question was, what is the probability that none of the 5 customers will order vanilla flavor? So we would type it in as follows. Equal Binom.DIST, that's the function, and then 0 for X, 5 for N, 0.29 for P, and false because we're not seeking a cumulative probability. We are going to do that next, but in this case we just want to know the probability that X is equal to 0, not greater than or less than, but equal to 0. So let's go to Excel and see how this works, and the answer we get in Excel should be the same as this that we did by hand, which was 0.18042. Okay, let's see how it's done in Excel. Okay, we're going to type in equal to Binom.DIST, open parentheses. Now it says their number of successes, and that's X, and X is 0. None of the customers order vanilla. Then we have comma, N, the number of trials, so there are 5 customers, that's the sample size. Then we have the probability of success, that is 0.29. And then we have whether it is cumulative or not, and the answer is no, we are not looking for a cumulative result, so we are typing in false. And when I hit return, you see the answer here is 0.180423. Now let's see what happens if we ask a different question. What is the probability that all 5 of the customers will order vanilla flavor ice cream? So when we use the function in Excel, the only thing that's going to change is X, and we're going to have 5 for X. 5N, P is 0.29, and the answer is still false. All right, let's see what happens when we do this. Okay, I'm going to type in equal to Binom.DIST, open parentheses. Now the number of successes in this case, when I'm asking what is the probability that all the customers, that would be all 5, so X is 5, N is still 5, P is still 0.29, and we still have false because it is not cumulative. Hit return and we get 0.002051. So the probability that all 5 of the customers will order vanilla flavor is 0.002051. Now let's say we ask a different question, and here's where cumulative comes in. What is the probability that at least 2 of the customers will order vanilla? This question requires us to think a little more carefully about how to use the cumulative option for the binomial function. Let's think about what this means. At least 2 means 2 or more, right? So 2 or more is 2 or 3 or 4 or 5 customers ordering vanilla ice cream. That would be written like this: the probability that X is greater than or equal to 2, right? So at least 2 of the customers will order vanilla is X equal 2, 3, 4, 5. So X greater than or equal to 2. The problem is Excel's binomial function cannot calculate greater than or equal to. It can only calculate cumulative less than or equal to. So what we need to do is we need to figure out the probability of X less than or equal to 1, because that's the flip side of X greater than or equal to 2. So that would be for X equals 0 or 1 customer. And that Excel will calculate for us, since it will calculate cumulative up to a certain number. So we can calculate the probability of X less than 2, so that is X equal to 1 or X equal to 0. and then subtract that from 1, since all the probabilities add up to 1, and we will get the probability we're looking for. So to get the probability we need, the probability of x greater than or equal to 2, we would do 1 minus the flip side of that, or 1 minus the probability of x less than or equal to 1. And that will give us the probability of x greater than or equal to 2. So let's see how that would be done. Okay, so let's see how we would do that. First we would have to calculate the probability that x is less than or equal to 1. And to do that, let's put that in the cell next to it. So the probability that x is less than or equal to 1 is equal to, we can type in Binom.DIST, and x then would be 1, comma, n is still 5, p is still 0.29, but now we would type in true because we do want it to be cumulative to 1. So it would be cumulative to 1 means 0 and 1. And when I hit return, it gives me 0.548892. That means the probability that x is either 0 or 1 is 0.548892. Now for the probability that x is greater than or equal to 2, I would do 1 minus that. So I can either do 1 minus that cell, which is H12, or I could type it in like this, equal to 1 minus Binom.DIST, open parentheses, and now I type in the same thing, 1, comma, n was 5, comma, 0.29, comma, true, end of parentheses, and I get 0.451108. And you can see if I add up those two cells, add up H12 plus H13, we get 1. Because that includes everything, the probability that x is less than or equal to 1, or the probability that x is greater than or equal to 2, so that includes everything, x 0, 1, 2, 3, 4, and 5. To make this clearer to understand, we can create a nice table for the binomial probabilities like this. Let's type in a title, binomial probabilities. Okay, and I'm going to put a title here, data. And then we can type in sample size, which is the same thing as n, and the probability of the event happening, or of the success, and that is p. And for our example, the sample size was 5, and the probability was 0.29. And now we can have the statistics. We are going to compute the mean. We can compute the variance, and we can compute the standard deviation. Now the formula for the mean for the binomial distribution is simply n times p. So n times p would be 5 times 0.29, but instead of typing in 5 times 0.29, I'm going to type in the cell reference. So I'm going to say equal to D5 times D6, and that is 1.45. That is the mean. Now the variance is n times p times 1 minus p. That's the formula for the variance, n times p times 1 minus p. Well, this cell here, D9, is already n times p. So I can use n times p, which is D9, and then times 1 minus p, and so I would put that in parentheses, 1 minus D6. And that gives me the variance. And finally, for the standard deviation, it is always the square root of the variance, so I would type in SQRT, that is square root, and the square root of what? The square root of D10. And that gives me the standard deviation. Okay, so now I have the statistics for the binomial, for this particular problem in the binomial distribution. And now I can set up a binomial table, binomial probabilities table for the various x's. So I can type in x, and I can type in here p of x, the probability of x, and I'll make a nice table. And so now we have the probability of x as 0. I can type that in as equal to Binom.DIST. And remember, x is 0. So I could either put in 0, or what I can do is, because I'm going to copy this formula down, I'm going to put in C16. And then when I copy it down, it'll be C17, C18, C19, C20, C21. Okay, so I don't have to type in x equals 0, then x equal 1, 2, 3, as you'll see in a moment. And then comma, the sample size, I can type in 5, or I can click on 5, but I want to fix it because I don't want it to then go to D6, D7, D8. I want it to be D5 always. Okay, so I'm going to fix this D5, but I want it to be $$ D and $5, so that it is fixed at D5 and not a relative cell reference. And the same thing for the probability of the event, which is 0.29, but I also want that to be a fixed cell reference. $, $. Okay, and then we have comma cumulative, and in this case we are saying false because we don't want a cumulative distribution. In a moment we will do a cumulative distribution. So we type in false and then end parentheses and press enter, and we get 0.180423. You remember that number from before. So now let's take that and pull the fill handle down so it copies and pastes that formula all the way down. Remember before we did x equals 0 that none of the customers would order vanilla, and then we did x equal 5, all the customers would equal 0, and we got 0.002051. All right, so this way we can fill in the entire distribution by just typing it in one time and then pulling it down to fill in the rest of the cells. But that only works because I had relative cell references for each of these C16 through C22, but D5 and D6 were absolute cell references. And so that is called a binomial distribution. And then we can create a cumulative distribution as well, and let's see what that would look like. Let me type in cumulative distribution, and we can put in the same thing, the x's. Now you remember from learning about cumulative distributions that that should all add up to 1, right? So cumulative, the last line on the cumulative distribution should be 1. Okay, so now what is the probability that x equals 0 through 5? When we get to 5, the probability that x is 0, 1, 2, 3, 4, or 5 should be equal to 1. So we should have a 1 here. And this should be the same as this, 0.180423. So let's type in the formula, but this time we're going to write true because we want a cumulative distribution. So let's type in equal, binom.dist, and then we have 0 as a relative cell reference, so that's H16 this time. And then we have D5, but I'm going to press function F4 to fix it. So I have $D $5, so it's D5 as the sample size, and it won't change. And then we put comma, and then we want D6, but we also want to fix that as an absolute cell reference. So function F4, okay? And then this time we type in true because we do want a cumulative distribution. And I'm going to close the parentheses. Now when I hit enter, we're going to get the same answer because cumulative to 0 is the same as not cumulative to 0 because there's nothing before it. But this number here, cumulative to 1, should be 0 plus 1. 0 plus 1 is 18,0423 plus 0.368469. So if you add those two together, we should get the cumulative to this point here. And what I'm going to do is I'm going to pull the fill handle down and have it filled in automatically. And now you can see if you take a calculator and add 0 and 1 here with the binomial probabilities, you will get 0.548892 as a cumulative. Cumulative to 2 is 0.8498. You can see if you add these three up, and if you keep adding all of these up, eventually you get to 1 or 100%. And that is a cumulative distribution. Let's see if we can create a chart. Okay, let's do a chart, a clustered chart here. And here we have a chart of this binomial probability distribution. You can see the probability of 0 customers, 1 customer, and remember the mean was 1.45. That would be a bar chart for the binomial distribution. Let me get rid of that, and let's see what it would look like for the cumulative distribution. And of course cumulative would look like an ogive. Let's do insert, recommended chart, and we want it to look something like that, like an ogive. And so you can see that 100% or 1 would be for 5 customers. So the probability of 5 customers or less is 100%, which makes sense. That's it. That's how you use Excel to create a binomial distribution table and a cumulative distribution table. Thank you for watching. I hope you enjoyed this video, and I hope you learned something.